In the circuit shown, two batteries with internal resistance are connected across a 5 ohm resistor. We are asked to find the current flowing in this 5 ohm resistor. Okay, so for this problem, uh, I will use two different methods. In the first method, I will use Kirchhoff's loop rule, and in the second method, we can combine these two batteries into a single battery, and then the circuit becomes really simple, and then we can get the current flowing through the 5 ohm resistor. Okay, so let's get started with the first method where we use Kirchhoff's loop rule. Now, Kirchhoff's loop rule says that if you take any point on a circuit, let's say if I take point C, I go around a loop, okay, crossing each of these circuit elements. And if you add all the potential drops or gains, okay, so they should all add up to 0. Okay, so the algebraic sum of the potential gains and the potential drops should add up to 0. Okay, so that's the Kirchhoff's loop rule. Okay, so let's see what we can do here. We need current flowing through the 5 ohm resistor. So let's assume that the current is flowing from B to C. If that is wrong, we'll get a negative value. Then the other direction is from C to B. Okay, so initially let's pretend it's flowing from B to C. Okay, so I is the current that we need, and let us say the current going from B to E is I prime. Again, if the direction is wrong, we'll get a negative value, and that is totally fine. Okay, and let us apply junction rule, okay, current law for that junction B. Okay, if I prime is going from B to E, I is going from B to C, from A to B, we should get sum of these currents, which is I plus I prime. Okay, so we have two unknowns here, I and I prime, and then we are after the value of I. And whenever you are solving such circuits, it's always recommended that if possible, use the Kirchhoff's junction rule right on the diagram, so that you reduce the number of variables. I think you will reduce it by 1. Okay, so it's always a good idea to show currents like this. Okay, now let's take two loops. I will I'll consider this loop. I'm going to walk in the counterclockwise direction. So let's put a number 1. So that's loop 1. And then here also we will move in the counterclockwise direction. So let's say that is loop 2. Okay, so let me indicate which loop I am looking at. So first we are looking at this loop. Okay, and then there are only two elements here, but don't forget the internal resistance here. So with that internal resistance, it's basically there are 3 elements here. Okay, so 1 6-volt battery, it has that internal resistance, and the 5 ohm resistor. Okay, so for loop 1, let's write for loop 1. Okay, as I go through the internal resistance of 2 ohms, okay, I'm walking in the direction of the current. Okay, so in a resistor, the current will always flow from a high potential end to a low potential end. So if you are moving in the direction of the current, there is a drop in potential. So what is the drop in potential? It is current multiplied by resistance. So the drop is indicated by a minus sign. So minus I plus I prime multiplied by 2. And for the battery, you're going from negative terminal to positive terminal. So there is a gain. So that is plus 6 and through the 5 ohm resistor again you are going in the direction of the current, so you'll go from high potential to low potential. That's a drop, so that is I into 5. Okay, and then this should add up to 0. Okay, so that should add up to 0. And then let's do the algebra here. What do we have? If I open it up, I have minus 2i prime plus 6 minus 5i is 0. I'm going to take the I variables to one side. So I have minus 2 minus 5. So that is minus 7. So if I take it to the other side, I'll have 7i minus 2i prime. I'll write it as 2i prime. This is equal to 6. So we have one equation here. Okay, now let us use the other loop. Okay, so if I use the other loop, so let me put it here. So loop 2. Okay, I think I should mention here loop 1. So that's loop 1. Okay, so let's use loop 2. Okay, so again the same thing. When I'm going through the internal resistance of the battery, I'm walking in the direction of the current. So there is a drop of IR. So here I is I prime. The internal resistance is 1. For the battery, so the voltage gain is plus 4. Okay, so here for the second loop, I'm going across the 5 ohm resistor from C to B, right? So I'm walking against the current. So the current is assumed to flow from B to C. So I have assumed B to be at a higher potential value. Okay, so B is at a high potential value and C is at a low potential value. But I'm walking against the current. So I'm going from a low potential value to a high potential value. So that is gain here. Okay, so I hope you understand that. So I into 5. Now this should add up to 0. So again here if I take the variables to the other side, 5i, I can write it as minus 5i plus I prime. This is equal to 4. Okay, so we are after I not I prime. So what we can do is in the second equation, I think I can multiply throughout by minus 2 so that I can add it to the first equation, sorry, and then we can simplify our algebra. So I'm multiplying the second equation throughout by minus 2. Okay, so I'm not multiplying by minus 2. That's the second equation. This is the first equation. Okay, so what do I have here? This is 10i minus 2i prime and this is minus 8. Okay, so now we're going to add this equation with the second equation here. Okay, so what do we get? 7 plus 10, that's 17i. Okay, 17i. And I prime disappears. We have 6 minus 8. So that is minus 2. So we get I as minus 2 by 17 amperes. Okay, so now pay attention to that minus sign. So we get a minus sign here. Okay, so since we get a minus sign, that means we assumed our direction wrongly. Okay, so the current, instead of flowing from B to C, it will actually flow from C to B. And you don't have to worry about the value of the current. That will be correct. Okay, so there is no problem there. The direction must be reversed. So the actual direction is from C to B and the current is 2 by 17 amperes. Okay, in the second method, we are going to combine these two batteries into a single battery and then simplify the circuit. I have put blue boxes around the batteries, and these two batteries are connected in parallel. Okay, so we're going to replace them with a single battery. So let's say we are not going to change these points B and C. We have 5 ohm resistor here. Okay, so now there is a battery that is going to come here. Okay, we don't know the polarity. Right now 6 volts battery has its positive polarity facing upwards. We don't know what will happen here, but there will be some internal resistance. Okay, so we can show that, but that's okay. I think we can just show like this by placing voltage, EMF and the internal resistance value here. But for this problem we are assuming that we know the formula for combining two batteries in parallel. Okay, so that's the that's something that we have to rely on in case we want to use this method. Okay, so when you have two batteries, let's say one battery has EMF E1 and internal resistance R1. The other battery has EMF E2, internal resistance R2. So when you combine, the EMF will be E1 R2 plus E2 R1 divided by R1 plus R2. Okay, and the internal resistance is very easy. Internal resistance is there in parallel, so you can combine them in parallel and get the internal resistance. Okay, so the easier part is internal resistance, so let us do that first. So we have 1 over R will be 1 by R1 plus 1 by R2. So 1 by 2 plus 1 by 1, that is 3 by 2. Okay, so remember R is 3 by 2. Sorry, 1 over R is 3 by 2. So the internal resistance here will be 2/3 of ohm. Okay, so 2 by 3 ohms. Now come back to the equivalent EMF of the single cell. Okay, I'm not writing the cell yet. I'm not drawing the cell yet because I don't know whether the positive polarity of the battery will face upwards or downwards. Okay, we don't know. Okay, but here you need to be careful. Look at the two batteries in the blue boxes. Okay, for the 6 volts battery, the positive terminal is facing upwards. Okay, for the 4 volt battery, the positive terminal is facing downwards. Okay, so when you use the values in the formula to get the equivalent EMF, you cannot just use the numbers here. Okay, so that will give you a wrong answer. Okay, so what you should really do is pick one of them as a positive direction. Okay, so and then if the positive terminal facing the other way, use the value with a minus sign. Okay, so here let us say that the 6 volts battery, because the positive terminal is facing upwards, we will consider that to be positive. Okay, so if that is positive, then this will be negative. Okay, so in the formula I'm using plus 6 here. R2 is the resistance of the other battery, internal resistance of the other battery, which is 1 plus E2. Okay, here again I'm drawing your attention here to minus 4 here. So be very careful here. Minus 4, and then R1 is 2 here, divided by R1 plus R2, 1 plus 2. So how much is this? This will be minus 8 by 3. Okay, so we got minus 8 by 3 volts. Again, minus sign is indicating that the positive terminal of the combined battery, or the one which we are going to replace these two batteries with, will be facing downwards. The positive terminal faces in the downward direction. So this is what we have. And the voltage is 8 by 3. Okay, so now I think once you do this, it is very clear that the current will be flowing from C to D. Okay, so there is no problem here. The current has to flow from C to D, and the 5 ohm resistor is in series with 2 by 3 ohm resistor. So the current value will be simply 8 by 3 divided by total resistance, which is 5 plus 2 by 3. Okay, so what do we have here? Okay, wait a second. I do this many times. Okay, why did I get 8? I don't know. I think I just multiplied 4 into 2 and then I started using it. Okay, I'm so sorry. Let's go back. Okay, so look at this. 6 minus 8. Okay, and then I just wrote it as minus 8. That is minus 2. Okay, so that is supposed to be 2. Okay. Okay, sorry guys. So that is minus 2. Okay, so this will be 2 as well. Okay, sorry for that weird thing popping up. Okay, so 2 and then 2 by 3, and then you have 5 plus 2 by 3, that's 17 by 3. So you get 2 by 17 amperes. Okay. So I think this method is, I think, faster when you are facing such a problem in the exam, especially when you have multiple choice paper. Okay, all right then.